This is a demonstration of Newton's rings apparatus and wedge fringes apparatus for advanced higher physics. So first of all, the equipment. We have a sodium lamp outputting orange light at a wavelength of 589 nanometers. We have a couple of glass slides, we have a little bit of paper, we have a lab jack. We have this, which is a piece of glass mounted at 45 degrees in a wooden frame. We have this circular piece of glass, which is curved on one side and flat on the other. I believe that's called a planar convex lens. And we also have a travelling microscope with a vernier scale. Here's the setup for the first experiment using wedge fringes. So I've got my 45 degree glass and my light source here. I have now added another slide of glass down here, parallel with the floor, and at 45 degrees to the glass. This may be difficult to see, but I've also added a piece of paper on top of that glass. And finally, I've added a second slide on top of the previous slide, but also slightly on top of the bit of paper there, so it forms a very, very shallow angle. The idea here is that the light coming from this direction will reflect off of this piece of glass down towards the two slides, and there'll be a very slight path difference, creating interference pattern between the two glass slides due to the slightly different angle that the light hits the glass slide. I've turned the lights out and moved the camera in, so hopefully you should be able to see some sort of pattern. It's not just good enough to see them, so I'll bring in the travelling microscope. I've added the travelling microscope in this configuration, so it is now looking directly down onto the glass slides. Here's the view from above, so you can see the sodium lamp is still here, and we're simply looking down the eyepiece towards the glass slides. Here's the vernier scale, which is important later. Looking through the eyepiece of the travelling microscope, you should hopefully be able to see distinct bands. These are the interference pattern from the wedge fringes. What we can then do is focus our crosshairs on one of the bands by twiddling the vernier scale adjuster, and then using the vernier scale, move from one band to the next and make them measure the distance apart. If I zoom out, I can show you adjusting the vernier knob, causing the scale here to move and the microscope to move ever so slightly towards the right of the screen. I'll move it a bit quicker so you can hopefully see a bit better. The next setup is for Newton's rings experiment, so same as last time. We've got our sodium lamp, 589 nanometer wavelength orange light. We've got our glass at 45 degrees. Well, this time we've only got one glass slide, and we've got our planar convex round glass lens. So same as last time, we've got our sodium light coming from this direction, hitting our 45 degree bit of glass. Again, I have added a large glass slide to the bottom of this, parallel to the ground. Except this time, instead of a glass slide propped up with a wedge of paper, we've got this round glass lens here, with the curved side facing the bottom, so that it sort of teeter-totters. And again, exactly the same as last time, we bring in our travelling microscope, so it's looking directly down on the 45 degree angle glass. You'll notice that this time, the interference pattern is circular as opposed to parallel lines like in the last one. This is Newton's rings. This is because we're using a circular piece of glass this time as a lens. And same story as last time, we can use the vernier scale to move between the middle point and this first dark patch, the second one, the third one, fourth one, and so on. And then write these values down that are shown on the vernier scale. As you see, if I continue to move it this way, the rings get closer and closer as you get towards the edge. That's because this is using a lens, whilst the previous one we were just using two straight pieces of glass. An important factor in the Newton's ring experiment is the curvature on the glass lens. For that, you can use a spherometer to work out the curvature. But I'm not going to do that because it's too complicated for me.